It just finished now. Okay, okay, I got it. So, and any idea? You don't have any idea which chapter is going to be next. So, have you must have got the syllabus, Mafaz?
No, sir.
Syllabus. You haven't got the syllabus for your half yearly exams yet.
No, sir.
Okay, okay, okay. So, whenever you get your syllabus for half yearly exams, update me with that. All right. So, the chapter that comes after heat, chapter number 3 was omitted, right? Synthetic fibers and plastics. That chapter was omitted from your syllabus, right, Mafaz?
Yes, sir.
Okay. So chapter 4 we discussed, that was heat. Now we have got another chapter, that is acid, base, and salts. Right. We have got new chapter. The name of the chapter is what? It's acid, bases, and salts. All right. So today we will be beginning with this new chapter. Okay then. Okay. See. Chapter is acid, bases, and salts. Right.
Yes, sir.
And salts. That is a chapter we are going to cover. All right. So you see, in our daily use, we are using different types of substances. Okay. Like there are different eatable substances which we are using. Like you eat lemon, you eat tamarind, you eat common salt, you eat sugar, you eat vinegar, and lot of different varieties of foods. Okay. You tell me, do all of these foods taste same or they have different taste? The foods which we eat on a daily basis,
Different.
its taste is different, right? Like whether you eat a tamarind or you eat a sweet, okay, or vinegar, that is silica, okay, or lemon. Their tastes are different. Tastes are different. Okay. So let's say I provide you few substances here. Okay. Like let's say you are provided with a lemon juice here, lemon juice, or I give you orange juice also. All right. Or you have curd. Okay, what is the taste of these type of substances?
Sir,
I'm
sour.
giving you options. It is sour, right? It is sour in nature. Okay. Or let's say I give you baking soda. Baking soda. Okay. And yes, sorry. Or I give you, let's say, baking soda, and let's say I give you a soap. Okay. So, what is the taste and touch of these substances? If you touch a soap and if you taste a baking soda, what is the taste? Is it sour or bitter?
Sir, bitter.
It is bitter. Okay. And it is soapy to touch. Okay. Baking soda is basically used in the kitchen in different types of foods. So if you touch baking soda powder, you will find it to be very soft. Okay. So it is bitter, soapy, and soft in nature. Yes, my first.
Sir, I think the next lesson is motion and time, chapter 13.
Chapter number 13 is the next chapter.
Yes, sir.
Okay, okay. Okay, that's why I was asking you, Mafaz, that which is the next chapter. Okay. Okay. So chapter number 13 is your,
Next
is
chapter.
this part of your half yearly syllabus?
Yes, sir.
Okay, okay. Do one thing. List all the list names of all the chapters which are part of your half yearly exam. Chapter number 13 and what else?
Because I don't know all of them, but the next lesson my ma'am told it will be motion and time.
Okay, it is motion. That is a chapter which the teacher was about to begin after heat.
Yes, ma'am.
Okay, okay. So we will do what? We will begin with the chapter number 13. All right.
Yes, sir.
Okay, okay. So just give me a minute. Okay. Let me just open the PDF. Okay. And did you completed the assignment work of us?
So
The
uh,
NCERT exercise, basically that was your assignment.
yes, sir.
Okay, you have completed that?
Yes, sir.
Okay, okay, very good. So do one thing, submit that as well. Okay, or have you submitted that already?
No, sir.
Okay, okay. First, you're supposed to submit the assignment after class. Okay, so
Yes.
kindly submit your assignment because I will get to keep track of your performance. Okay, okay, that is the chapter, right? Motion and time. Yes, this is your chapter. Okay, motion and time. Okay. So you see, in your previous class, you must have studied about different types of motions, right? There are circular motion, there are rectilinear motion, straight line motion, oscillatory motions, right, Mafaz? Okay. So
Yes.
motions are of different types, and whenever we study motion, we also study motion in respect to time also. Okay. Like when we calculate the speed of different objects, we calculate them in terms of time. Like a train is moving, let's say it is moving at a speed of 300 kilometer per hour. So notice here we have included time factor also here, right, Mufaz? So whenever we talked about motion, we got to talk about time factor also, right? Okay. So in your previous class, you must have studied that motion could be along a straight line, like a person walking on a street, like a person going for a morning walk on a street. That person is simply walking on a straight line. Okay. Or if you're walking, or if you are driving a car and you have to take turns, then you make a make a curved motion. Okay. Similarly, you have circular or periodic motions also. Okay, so periodic motion that is happening at a regular interval. See the pendulum of a clock, right? It moves like this, to and fro, back and fro. Okay, so its motion is regulated by time. Okay, so in a given, let's say for 10 seconds, okay, in 10 seconds, the pendulum is going to do a fixed number of motion, right? So that type of motion is called periodic motion, right? Are you able to recall these type of motions? Okay. Or you have circular motion also, right? So if an body is moving around a given body in a circular fashion, that is called circular motion, right? Okay. See here, examples of different types of motion given here. Okay. Let's classify them under which category they fall. Soldiers in a march past. Is it a straight line motion or circular or periodic motion? Soldiers in a march past. March past, when they are doing a parade. That is in a straight line.
Yes, sir.
Okay, so that type of motion is a straight line motion. Bullock cart moving on a straight road. That is straight, circular, or periodic?
Straight line.
Straight line. Okay, what about next one? Hands of an athlete in a race. You see how hands of an athlete moves in a when he is in a race, how he
Period.
moves in a periodic motion. Very good. Periodic motion. Okay, pedal of a bicycle in motion.
So circular.
Circular. Very good. Circular motion. Motion of the earth around the sun.
Circular.
Circular and periodic both. All right. Motion of the earth around the sun. This is your sun. This is your earth here. This is your sun. This is earth. So it is doing a circular motion around the sun. Okay. While it is doing this circular motion at a given period of 365 days, right, Mafaz? So there's a fixed time period for this motion also. So this is both circular as well as periodic motion. Okay. Motion of a swing.
So periodic.
Motion of a swing. Swing. What is swing here?
So periodic.
That is periodic. Motion of a pendulum. That is also
Periodic.
periodic. Very good. Okay.
So, so every circular motion is periodic motion.
Is this my pass?
So every circular motion should be periodic motion, right?
No, it's not necessary. Okay, it's not necessary. Like if I take a piece of thread and tie a stone on one end of the thread and roll it like this, it will be a circular motion, but I can change the rate of the motion. Like I can start to rotate the piece of rock very quickly, or I can slow it down also. Okay, so periodic motion will happen when there's a fixed time period for motion. Okay, like in a pendulum, we see the motion is in a fixed manner. Okay, it just the pendulum does not starts to move very quickly, or it does not suddenly becomes it does not suddenly starts to move very slow.
So motion of a swing.
Motion of a
That motion of a swing.
yeah, motion of a swing also, you see, it depends. In case of a motion of a swing, it depends. Yeah. Okay, it could be periodic or it could not be periodic. Right.
Yes.
Okay. Now you see, it is a common experience that the motion of some objects is slow while that of some others is fast. Okay, that is a normal thing here. So how do we determine whether an object is moving slow or fast? Yes, Mafaz. See, what does it says here? We know that some vehicles move faster than others. Even the same vehicle may move faster or slower at different times. So make a list of 10 objects moving along a straight path. Group the motion of these objects as slow and fast. How did you decide which object is moving slow and which one is moving fast? So when we are considering the slow or when we are considering the speed of object, how do we determine whether this object is moving faster or slower? We consider time there, right?
Yes.
So time comes into discussion there whenever we are talking about the motion of a object, whether it's slow or fast. So time determines speed. Okay, and there are some other factors also which we will be talking here. Okay, look, there's an activity here. Okay, so there's a figure given here, figure 9.1. Okay, look this figure, there are several vehicles running on the road. Okay, now what does the activity says here? It shows the figure is basically showing the position of some vehicles moving on the road in a same direction at some instant of time. Okay, It could be any given time in the clock. At that time period, these cars are moving on the road. Okay. So now look at figure 9.2 here. Okay, what do you observe in the two figures? Are the position of vehicles same in both the figures, or some of the vehicles have changed their position?
So some of the vehicles have changed the position.
Right, like this green vehicle have moved forward. Okay, the red one is it has remained backward. Right. Okay. So which vehicle is moving the fastest of all of these vehicles? Clearly that is green one here. Right. So that is a simple activity here. Any kid could can simply determine that what is going on in the two activity here. Yes. So here again, it says that the distance moved by objects in a given interval of time can help us to decide which one is faster or slower. Okay. So let's say your given time period is 30 seconds. Okay. On your timer, you have set it to 30 seconds, and you take two vehicles, and you have taken a distance of, let's say, 100 meter here. Okay, now you have got vehicle A and vehicle B. Okay, so let's say vehicle A covers this distance. Okay, cover is able to cover the distance, and vehicle B is only able to cover half of the distance. So clearly, which vehicle is having more speed here?
The vehicle A.
Vehicle A, obviously here. Okay. So the time taken by the vehicle A, let's say if I say the time taken by the vehicle to cover the distance was 25 seconds, and the time taken by the vehicle to cover the distance, the half distance, that is 50 meter. Okay. It was how much? Let's say it was 40 seconds. So in this case, which vehicle is having more speed?
The vehicle A.
Again, vehicle A. Okay, so time is a very deciding factor when you are calculating the speed of any given object. Okay, so it is easy to decide whose speed is the highest. One who takes shortest time to cover the distance of 100 meters has the highest speed. So how do we define the speed here?
So by checking the time and the uh, by checking the time how much it was.
Yes, by checking the time,
Uh,
how much it took to cover the given distance. But
yes.
in numerical terms, how do we explain this? Let's say we know basically speed is nothing but it is the uh, it is it is the distance covered in a given time. Okay, it is the
Lasting.
ratio of distance and time for a given object it takes to move from one place to another. In numerical terms, how we do define this speed here?
Like 300 km/h.
Exactly. Okay, so when we say that 300 kilometer per hour, we are basically saying that 300 kilometer was the distance traveled in 1 hour. So speed is equals to distance upon time, right, Mafaz?
Yes, sir.
Okay. So we call the distance covered by an object in a unit time as the speed of the time. So that is the definition of a speed, that the distance covered by an object in a unit time is known as the speed of that object. Okay. So when we are saying that a body is moving with a speed of 50 kilometer per hour, it implies that it will cover a distance of 50 kilometer in 1 hour. Okay. So these are some basic. Now, let's say Okay. So we were talking about the speed. Okay. And speed we defined as it is the ratio of distance. It is the ratio of distance and time, or we say that it is the amount of distance covered by an object in a unit period of time. Okay. So if an object has traveled 50 kilometer of distance in, let's say, 1 hour, so its speed is going to be 50 kilometer upon 1 hour, that is 50 kilometer per hour, right, my first. But
Yes,
let's say, but let's say I am on a journey. Okay, and I am about to cover the journey. I have divided my whole journey into two parts, part A and part B. All right. And the total distance of my journey is 100 kilometer. Okay. So for first half part of the journey, my the speed of my car was 25 kilometer per hour, and for the next half part of my journey, the speed of my car was 35 kilometer per hour. Now, if someone asks me what was the average speed of my car during this whole journey, how do I calculate that?
sir, by adding it and dividing.
Exactly
So
by adding the two speeds.
the 60 by 100,
No, by two. It is by two. Okay. So that gives me how much?
30.
60 upon 2, that is 30 kilometer per hour. So that was now the average speed of my car during the whole journey. Right, my fast.
Yes, sir.
So speed is one thing and average speed is the thing. It is basically the average speed taken by the vehicle to cover the distance. Because in the journey there might have been several barriers due to which the speed of my car has been reduced. Okay, so that is how you calculate the average speed. Okay, now see, that is pretty simple to calculate. But you see, average speed can be calculated in some other ways as well. Okay, so now let's say for the same question, I'm making some changes in this one. Okay, say that the whole journey is of 100 kilometer. Okay, and I'm for the part A of the journey, I took how much? I took 2 hours to cover this journey. Okay, that is of 50 kilometer, and part B is also of 50 kilometer. And for to cover part B of my journey, I took 3 hours. Okay. Now in this case, how am I supposed to calculate the average speed? And let me tell you also one more thing, that the speed take that speed for the speed in covering part A of my journey was how much? It was 25 kilometer per hour. And the speed of my vehicle while covering part B of the journey, it was 50 by 30 kilometer per hour. Now in this case, what is the average speed of my vehicle? So in this case, what we are going to do, we are going to calculate total speed. Okay, We are actually going to calculate total distance here, not the speed. Okay, you will calculate the total distance here. And you will see the total time taken. Okay, so what is the total distance?
Sir, 100 kilometers.
100 kilometer. And what was the total time taken to cover this journey?
Sir, 5 hours.
5 hours. So here I get it's 20 kilometer per hour. Okay. So 20 kilometer per hour was the average speed of my car while covering this distance here. So that's another method of covering the average speed in to cover the journey. Okay. So let me summarize it, what we have discussed so far. So first thing is that speed, we basically know it is distance upon time, and it could be in kilometer per hour or meter per second also. Or let me first. Next thing is average speed. Okay. So average speed, how do you calculate this? You calculate speed 1 plus speed 2 upon 2. Okay. In which case you are going to simply add the two speeds and divide by 2 when equal distances are traveled. Equal distances are traveled. Like this is a journey. Let's say it's of 10 kilometer and it has been divided into 5 kilometer each. Okay, and you are provided with the speed that for the first 5 kilometer it was 25 kilometer per hour, and for the next half of the journey it was, let's say, 30 kilometer per hour. So in this case, you see the journey has been divided into two equal parts. Hence, you can simply add the two speeds and divide it by 2. Then you will get the average speed. Now let's say you are provided with time. Okay, you are provided with time instead of speed. Then how we calculate the average speed? We will simply calculate the total distance of the journey and divide it by total time taken to cover the journey. Okay, Mufaz. So do one thing, take note of these three formulas. Total distance divided by total time taken. So note these two formulas in your copy. Yes, my fast done.
No, sir.
Okay.
Yes, sir. Done, sir.
Okay. Now, you see, next thing we have to discuss is the types of motion. Like we already know about there are types of motion like rectilinear motions, straight line motion, and periodic motion. Okay. But another type of motion is uniform and non-uniform motion. Uniform and non-uniform motion. Okay, so what are these things now? You see, so when an object is moving along a straight line with a constant speed, then we say that that object is moving at a that object is moving in a uniform motion. A body moving on a straight line without changing its speed. Let's say there is a car running on a straight motion here. Okay, and the car does not changes its speed. Let's say its speed is, let's say, 25 kilometer per hour. Okay, and it keeps on moving on the straight path with the same speed here. So that object is said to be moving at a uniform motion. Okay, but what happens along the path? There comes a curve. The road changes. So during changing the road, the car have to slow down, right, Mufaz? So in that case, we will say that now the car is moving at a non-uniform motion. So when an object moving along a straight line changes its speed with respect to time, then the object is said to be moving in non-uniform motion. Look, uniform motion. How do we define this? When an object is moving on a straight line without changing its speed, then it is said to be in a uniform
Uniform
motion,
motion.
right?
Yes, sir.
Okay. Then next we have got a non-uniform motion. So what is happening in a non-uniform motion? Okay, when the person changes his speed with respect to time, okay, when the person changes, when the object changes its speed with respect to time, then that object is said to be moving in a non-uniform motion, right? So when, and take notes of these definitions, okay, do write them in your copy. So when an object is moving along a straight line and changes its speed with time, then it is said to be in non-uniform motion. Okay, first note these down and note their examples also. The motion of a train is an example of a uniform or a non-uniform.
Uh, Both.
No, usually the motion of a train is a non-uniform motion. Okay, sometimes it slows down, sometimes it's fastens, right? And uniform motion is what? A car running on a straight path. Okay. Miss Mafaz, you can hear me?
Yes, sir.
Okay, okay. Yeah, actually the light just went off. Yes, Mafaz. Shall we move ahead then?
What, sir?
If you Shall we move ahead then if you are done?
I'm not done, sir.
Okay, okay. Take your time.
Yes, sir, done, sir.
Okay. Now, next thing we got to discuss is how do we measure time? Measurement of time. Okay, we are basically going to talk about the units in which we measure time. Okay, so the time, it is basically measured in seconds, minutes, and hours, which you already know. And what is time period? It is basically the total time taken by an object to complete the oscillation or the movement. Okay, so time, it is measured in second, minutes, and hours. Okay, and one more term related to time is time period. Okay, so what is time period? If you remember oscillatory motion. Okay, so oscillatory motion was what? If you remember a pendulum, this is a pendulum, right? So when this pendulum does a complete motion from its mean position, this is the mean position, the resting position of a pendulum, right, Prafas? So pendulum goes from its resting position to here, right? And then again it will go to this position, right? So these are its extreme position. Okay. So one complete motion of a pendulum is what? From its mean position, it pay attention here, Mafas. From its mean position, it will go to the extreme position A and it will go to the extreme position B here. Okay. And then come back to its mean position, then come back to its mean position. What is happening? A pendulum completes one full oscillation when it moves from its mean position to extreme position A, then from extreme position A, it moves to extreme position B, and then again come back to its mean position. Okay, so that is called one complete oscillation. So what is time period? Time period is basically the time taken by the object, or in this case, this pendulum, to complete one oscillation. So the time taken by an object or slash a pendulum to complete one oscillation is called time period. Alright, so that is it about, you need to know about time in this chapter. Okay, units of time, it is basically second, minutes, and hours. Okay, unit of speed, you already know, it is kilometer per hour and meter per second. Okay, now there are two components which are attached in devices. One is now the speedometer, and the another one is odometer fast. Okay, so if you sat on a bike, you must have seen there are two different meters showing readings. One meter shows the speed at which the bike is moving, and the another meter shows how much distance the vehicle has traveled so far. It is attached in cars and tractors also, right, Mufaz?
Yes,
So
sir.
you have got speedometer and you have got odometer. So speedometer is what? Speedometer records the speed of the moving object directly in kilometer per hour. All right. And what does an odometer do? It basically calculates the distance traveled by the object also in kilometer. So notice these, note down these points also. Okay, instead of object, right here, vehicle. Okay. Yes, Mufaz. Done?
I'm going to, sir.
Okay, okay.
Yes, sir. Done, sir.
Okay. Now, next thing is we are going to derive a relation between distance and time with the help of a graph. Okay. So see here. Let me see if I can attach a graph here that will give a better idea. Anyways, leave it. Okay. So next thing is distance time graph. Okay. So let's say we are told to trace the motion of a vehicle on a piece of graph paper. So how do we trace that? So on a graph paper, you see there are so many boxes. So we will draw two lines on a graph paper. Okay. So those lines we call them axis. This one is being called as x axis, and this one is called as y axis. Okay. So on the x axis, we are representing distance. We are representing actually time, not distance. Okay. And on the y axis, we represent distance traveled by the object. Okay. So say the time is like this: 5, 10, 15, 20, 25. These are all in minutes, Mafaz. Okay. And on the y axis, we have got this reading of distance traveled by the object, by the vehicle. So let's say it is 100 meter, then it is 200 meter, then 300 meter, 400, and 500. So notice we can actually find out the speed of the object from here. So at time 5 minutes, how much distance was traveled by the object? It was 100 meter. Right, Mafaz? At time when the time was 10 minutes, the distance traveled by the object, it was 200 meter. Okay, so this is the point representing the speed of the object at time 10 minutes. When the time was 15 minutes, then the object has traveled 300 meter of distance. So see, notice here, this here is 100 meter upon 5. So when the object has after 5 minutes, when the object has traveled 100 meter, the speed of the object is represented by this 100 upon 5. That is what? That is 20 meter, 20 meter per minute here. Let's say it's better to represent it in second here. Okay. So when the time was 5 minutes, the object has traveled 100 meter of distance, and at that time, the speed of the object was 5 minutes per second. Now, similarly, see here when the object, when it was 10 minutes, the object has traveled 200 meter. So at 10 second here, what was the speed of the object? It was 200 meter upon 10 second. That gave you 20 meter per second. Right, Prabhas? Similarly, when it was 15 second, the object has traveled 300 meter of distance. So in this case also, the speed can be calculated. That is 300 upon 15 second. That gives you 20 meter per second. So you see, there's a slope we can actually draw from here. See this thing here. Connect these lines here. Prabhas, see, connect these dots here. This one. Let me first erase these ones here. You see here. Let's connect these dots here. Okay. So when you connect these dots here, you are getting a line here, a straight line here. Okay. So this straight line is called basically slope of the graph. Slope of the graph. Is the slope of a graph? In any case, when you have got a graph like this and you match the corresponding data given on x and y axis, and when you match the corresponding data and you get it like this, so when you are joining the points, you get a straight line. So that straight line is called simply called slope of the graph. So this slope of the graph is not giving you a speed of the object traveling here. Like this point represents 20 meter per second of speed. Again, this point represents here 20 meter per second of speed. Right, Mufas? Are you getting this or is it confusing? Yes, Mufas.
Yes, sir.
Okay. So when you are uh, when you are corresponding the value of value of x-axis and y-axis, when you join them together at the point, that point basically is representing the speed of the given object here. Okay, so for first 5 minutes, the speed of the for first 5 seconds, the distance traveled was 100 meter. For first 10 seconds, the distance traveled by 200 meter. And the points corresponding to them here, when we joined them, we got the slope of the graph. The slope of the graph, it represents